Hey, what's up, my people? It's me, Professor R, back on B.E.I.N.G. I'm here again. I always come talk to you by being this is me, the content creator of B.E.I.N.G, being myself. I'm just being myself, man. I'm here sitting around, watching out this beautiful outside. People, you can see. I'm just out here chilling, man, on a Saturday night. And man, look, I want to share something with y'all, man. Like, the thing that I love the most, comment, like, and subscribe to all my other channels. If you see my name, pull my name up, you'll see the other ones that I have. Comment, like, and subscribe to all my channels. Now, let's get into the analytics. Listen, man, when I first made this, I thought, man, what can I do to improve on things? I see content on YouTube and everything, but the thing that caught me the most, like, man, chemistry. Now, why you say chemistry? Chemistry. Everything has chemistry, right? The main thing I always want to improve on is a lot of things that I couldn't improve on. But let me say something. Chemistry is what two things come together. Molecules bring things together, right? Mass, molecules. Everything has molecular structure, mass and molecules. Molecules bring together, like shooting a basketball. That's a molecule of mass, because it's a formula to shoot it, because you have molecules and mass that you're putting together. Now, cooking is another molecule that a lot of people don't know. Now, cooking has molecules and mass because everything has chemicals in it. So I want to know what makes us have mass and molecules. Like, when people cook on the grill, right? That's mass and molecules. But here, what makes that official? Now, for example, when you're cooking on the grill, right? You see that right there? Cooking on the grill. That brings molecules and that brings mass. So you cook the grill because this grill got to be hot. And this is the molecules to have a temperature. Because everything in our body has a temperature. Mass and molecules go together. So, like, if you have a temperature, right, everything has a certain temperature that goes with it. Like, when you working at McDonald's, or when you go into, like, Smart and Final, which is over here. See that right there? That's a Smart and Final over there. They use a thermometer to check the preheated chicken at a certain temperature. Everything has a temperature. Even our bodies have a temperature. Now, in my understanding, in my research, temperature, mass, and molecules, you got to have a formula with that. Now, see, here is a formula right here for mass and molecules. You can see the formula for what it is. Because, man, look, there's mass and then there's molecules. How do you combine them together? There's a certain formula. Now, I'm going to take my glasses off so y'all can see me. What is conserved? Molecules conserve energy, right? But energy is in cooking as well. So you can see the molecules right here, right? The mass of molecules, which is what you cook, is like a vacuum, plus the mass of the product. Whatever the product is, there's a chemical formula that goes to it, especially when you barbecue it. Now, we are what is called conserved because it deals with the mass of molecules. Now, the reason why I show you that, because I wasn't aware of that before. Like, temperature, especially when you're barbecuing, you have to conserve what the barbecue is, and you have a certain chemical compound that's underneath it. I didn't know that. Right now I know. When I bought this book, I wanted to learn, why do people make great barbecue? Because it's a chemical. See right here, let me take this off. Chemical compound. See, it's a chemical compound that goes with the mass and molecules. See, it's a chemical compound. Charcoal is a chemical compound. See, right here, you can see the compound right there, right? It tells you why it gets a certain temperature. Now, I wasn't aware of that because it's the product. Now, some of y'all may say, man, what does this got to do with today's episode? Well, we all have chemistry, mass, and molecules because it's conserved. Conserved means, like, your energy, and it conserves constellation. Like, see right here, it tells you what it means right there. It tells you about mass. See, it's conserved energy that we don't know. Our energy has to be conserved. Like a lot of people have energy, but it's not conserved because they use too many molecules and mass. People give away this chemical energy and then let other people take it. Our body gets drained because we're giving people off our chemical mass. That is conserved energy that is in our bodies that we supposed to conserve. Now, you say, well, Professor R, you always come up with these different things. But let me tell you that we have to conserve our energy because stored energy is in our body. Conserved means stored up energy, built up molecules and mass that is stored up in our bodies. This is why chemistry is important. Chemistry. We all have chemistry in our body. Now, how do we store this energy up? Because chemistry is conserved. That means it's saved energy. It is restored inside of our body because we have a mass of molecules that is stored up in our bodies, and that's how we conserve the energy. A lot of the times, molecules are in when we play basketball. Basketball has stored up molecules. And you say, how do you discover that? Well, for example, I'm going to show you guys mass and molecules go together because it's stored up. For example, as you can see, the young lady shooting the basketball, you can see how she's shooting. See what it says? It said, that's the name of it at the top. If you can see that, hopefully you can see that. See how she's shooting? Because she has mass and molecules stored up inside of her. So mass and molecules are stored up. This is what we use when we shoot basketball, right? As you can see, the mass and the molecules are combined together. That's stored up molecules that is going inside her body to shoot a basketball because she's reserving energy. She's using her whole body to store up the molecules. As you can see, it tells you right there why she's able to shoot, and it has a name right there. Now, some of you probably don't understand that, but when you shoot a basketball, you have to shoot it. It's stored up energy, right? So energy is stored up. So the molecules in the mass, you're using a lot of it. So that's why she's able to shoot. Now, you probably saying to yourself, that's R, you always come with the weirdest stuff. But listen, we always use energy. We use mass, bro. Like we use stored up energy that's in our bodies. Chemical energy is conserved. We reserve our energy. But look, let me share some with y'all, man. See how I'm using the energy to open the door? The reason why I use the energy to open the door, bro, because, see, energy is stored up. We have mass and molecules. Now, sometimes we may not know what that means, but it's stored up energy. Chemical compounds is in our body, right? We have a lot of chemical compounds, CO2. We have iodine, which is Fe2, which is salt. We have, what's another chemical you can think of? You know any more chemicals? Yeah, we have iodine. We have, CO2 in our body. We have stored up cells. If you look at the periodic table, if you go to this book, chemistry, buy this book, by the way. It's a great read. I think a lot of y'all see, look, see? Stored up cells. Now, we have light. Let there be light. Okay, I open the door so y'all can see. Now, see the chemical chart? Right here is a chemical chart, right? Now, where's Fe? It's iodine, right? Iodine is stored up salt in our body, right? Iodine is in our body. I'm going to take these off so you can look on the chart. I'll look with you. Now, you see this chart, right? Stored up iodine is on the chart. Now, where's Fe in the chart? Can anybody know what Fe is? Fe is iodine, which is salt. Okay, you have CO2. You have water. We have water in our body. We have salt. We have iodine, which is salt. We have different chemicals. I love this chart because in school, I didn't understand this chart. But the periodic element is in the middle. So if you look at it itself, look what it says. The element symbol, we have atoms. The atoms is the top of the symbol. So the atom is there. As you can see, Fe is on here somewhere. Did anybody see it? Fe. That's iodine. I know it's here in the chart. If you see it, please Just point to it. You guys see it? Fe. Well, anyway, we know what the periodic table look like. So I just thought I'd share that with you. That chemical compound comes in our body. Now, this is another thing I'm gonna share with you. See that right there? Yeah. See, change the state of matter. Our body have changes the state of matter. Sorry. Look at our body. Change the state of matter. See? We change our body as a state of matter. Matter is a chemical compound that is based on our body and our stored up cells. Now, a lot of us use different energy. People use energy all the time. Main thing is a chemical reaction that we get from it, especially when we're cooking. You guys got to remember we have stored up energy in our body. See? And I'm just going around the book so you guys see why I bought this book. But see, here's the thing. There's changes to our body. We have different phases. Heat is a phase. It's a state. It's a phase, right? See, this is how the state changes. See the chemicals that are standing up here? Yeah, solid. Yeah, see, it jumps. Liquid. See how it jump? Yeah, that's how our body gets heat. It's phases. We go to different phases, we get heat. So I'm showing you, the reason why I'm showing you this is because it's a reaction. Reaction phase helps us store up these cells. He said, Professor R, what does this got to do with chemistry? A lot of it does. Our body are made of chemicals. It's stored up chemicals that changes to different states of matter. And if you, like me, is a fan of chemistry, everything we do has chemistry, right? Everything we do. Even water in mountains has chemistry. Compounds, compound solids, molecular geometry, compounds, everything has chemistry. Even copper, see? I'm just going through the book so I can see you guys. Now this is a different thing. This is interesting right here. I'm just showing you guys what's in this book. Why the weather changes sometimes. Look at that. Look at that. That's interesting, right? That's why I love chemistry. See the weather patterns. Say to times why earthquakes happen. The earth shifts, and the weather changes. I'm just showing you guys weather patterns. See the weather patterns? You see the weather patterns? All this has to do with our the oceanic, lithosphere, yeah. And this is why the weather changes. Paleomagnetic data. Data changes, see? It's good to get these things so you can know why the earth changes dramatically. Because a lot of people don't know. See, I'm just showing you guys little things like the ocean itself, the mountain right there, boundary spread, and, different things, man. Just chemistry is fun to know. Atomic structure, as you guys can see, atoms, neon, see, neon. Remember, I told you, neon, and why things have neon in it, like different animals have isotopes, atomic mass, mass of piano. I'm just showing you guys different things, birds, atomic, chemistry. Well, that ends today, and I hope you guys enjoyed this time with Professor R. As always, comment, like, and subscribe. Get your chemistry book today. And on the next time on B.E.I.N.G, we'll talk about something else, maybe the Bible. We just talk about different things. So you guys like this, comment, like, and subscribe. Tell me what you think about today's episode. Tell me what you like about it. Tell me what you didn't like about it. And please, comment, like, and subscribe to all my channels. Type in Professor R and all my channels should show up. I really appreciate your time. I really appreciate you guys on B.E.I.N.G. I really appreciate it. Keep subscribing, like, and comment. Leave this open. And I'll see you next time. Professor R on B.E.I.N.G. Stay tuned for more episodes. May you be blessed. Later.